we are given an integer array names, and they are sorted in a long decreasing order. We have to remove the duplicate in place, such each unique element appears only once. The relative order of the element should be kept the same. Since it is impossible to change the length of the array in some language, we must instead have the result being placed in the first part of array length. For more formally, if there are k elements after removing the duplicates, then the first k element of the length should hold the final result. It doesn't matter what you leave beyond the first k element. Return k after placing the final result in the first k slot of the length, and we can allocate extra space for another array. We must do this by modifying the input array in place with all of one extra memory. We only want to each number to appear once, and we remove the duplicates in place but don't change the length of the integer array. After removing them, when we renew the array's names is going to have the same length, but some of the orders change. The first part is keep a sequence order, and the last part is remaining the last element. This could be anything you want to be, because they don't matter. What actually matters is that each element appear once, and they are in orders. It is the first unique element that matter, and we are going to return those unique elements, and then the names array keep the same size. Only the first distinct numbers in orders that matter, and the last element could keep the same. They don't matter because we are seeing those before. We only need those first appear numbers, and if they appear more than once, we just ignore them, and then we return only the unique number. In this problem, the key point is focused on is the input array being sorted. As far as the duplicate elements are concerned, what is their positioning in this array when the given array is sorted? If we know the position of one of the elements, do we know the positioning of the duplicate element? Of course, we need to modify the array in place, and the size of the final array would be potentially smaller than the size of the input array. So we ought to use the two-pointer approach here. One is that would keep track of the current element in original array, and the other one is just used for the unique element. Essentially, once a number is encountered, you simply need to bypass the duplicates and move on to the next unique element, because the array is sorted, and we can compare the two adjacent elements to know if we need to include one of them in the result. If we scan the array from left to right and find two adjacent elements that are the same, then the one in the right can be ignored. As we scan them from left to right, if I made some second or third same element, we know that we are already see them before. That doesn't help me because I'm trying to remove the duplicates. Nothing special happened. But if I'm looking for two adjacent elements, they are different, then that means I seen it in my first time, then it is sure include in my result. Then we include the number in the result because this is the first time we see it. So in this algorithm, we iterate through the array. We will compare two adjacent elements with each iteration. If the elements are different, then we are discovering the element in the right side for the first time. When it happened, we need to add it to the correct location in that array. The location to insert the next distinct element can be tracked with another variable. I will call it the insert index. Whenever a number is first time discovered, it can be copied into the insert index. Then the insert index can be incremented. If our array are not empty, that means we can ignore the first element and start with the second. Why we can ignore the first element? Because the first time I will see the number, So it is guaranteed that I have never seen that before. But it has to be my result, and the array is still needed to be sorted from the smallest to the largest, and the number is guaranteed it to still be smallest just by removing the duplicate element from the sorted array. We want to return how many distinct elements there are, and insert index can actually help us with that. And after we are done with the loop, the insert index will point at the index with the first element that contain duplicates. Because array are zero index, and we can use insert index as we return the value for our method. So how this algorithm performs in action? We can ignore the first element because it guarantees it is the first time we see it. So we start with the second one, and I create an additional variable called I. That will be my loop index for check, and it starts from the index 1. We compare it with the one before it. We compare the first element and the second one. If they are the same and equal to each other, then we don't need to make any change, but ignore them and move on. We only care if the number we are looking at and the number we refer it are different. So when they are different, when we compare the number and the number before it, they are different. That means this is the first time we see it. Then we need to bring that number to insert the index point location, and then I update my insert index in our loop, and each iteration we have to update I, and I'm now done with my for loop. I variable can find more element, then the insert index is pointing at the last index. So if there were more number to process, if I saw some number in the first type, I will definitely put the number into this last index. But we are done. So the insert index is pointing at the final number, and we have to return number of the distinct element, which is precisely the final insert index point. If we return the insert index itself, it would be the number we're looking for. So this n is better solution because the time complexity is turned to O of n, and the space complexity is a constant of 1. Let's try to implement the code into Python. Class solution, define, remove, duplicate, self is an integer array, and return an integer, and initialize n is the length of the length array, and if n is 0, then it's empty array, so we return 0. And initialize insert index, start from 1 because we keep the first row, because the first one is already a unique one, and assume the n is the length of the array. We have 2 pointers. They can traverse almost n steps, so we'll have n loops. So the time complexity is O of n. So we have a for I in range, start from 1 and keep 1, skip 1, and end before the n minus 1 is biggest, and every time incremented by 1. If length at I isn't equal to length at before 1, I minus 1, then the length insert underscore index is get the element copied from the length at I. and then the insert underscore index increment 1, because we just use that. And if it not, then we will skip to increment the insert index, but the I is increment, so the I is the faster iterative pointer. And after we finished, we can return the insert underscore index and names. We just want to see what happened inside it, and we can print solution dot remove duplicates. Okay, we print the two output. The first one we get the okay, this. Oh. Oh, and the second one we get this. Yeah, here we go. We return the 2. The first one 2 is number of first 2, and this is 5 0 to 4. So this 5 return this 5. So the answer is correct.